Great. So my name is Dave Jackson, and my friends call me Cave Dave. And the reason they call me Cave Dave is that I built this really cool cave that I'm going to take you to see. It's over here. It is in a big trailer. And some of you may have seen this before at Cool Science. We've been doing Cool Science since 2011. And if you've seen this before, why don't you give us a thumbs up in the chat window there, or come off mute.
And if you want to turn on your cameras and go off mute, that's great.
Yeah, great, awesome. So if you all want to turn your cameras on, you're welcome to, and that way I can see what you think. Here's my son, William. He has his helmet on. This cave here is a horizontal cave, So if you have your camera, oh, I see you guys. Can you guys, Ella and Garrett, can you guys show me horizontal with your arms? What does horizontal look like? Which way is horizontal? Hold your arm. Good job. That's awesome. They got it. Yes, horizontal is this way. Now, this cave is, it's about 60 feet of tunnels, and there's a little bit of climbing in there. But some caves are really deep. And if you know what the opposite of horizontal is, why don't you go, and even if you're having trouble spelling it, why don't you go and write that in the chat window? What is the opposite of horizontal? Or you can come off of mute and you can tell me what is the opposite of horizontal. So this cave here, William, come on over. This is a fake vertical cave. Vertical is the opposite of horizontal. Vertical is up and down this way. And some caves are really, really deep, right? People go many thousands of feet underground to explore really deep caves. And we can't have a really, really tall trailer. So instead, we've got this really cool tower. It's here, sorry about the camera motion. And we are going to lift William up. We're pretending that we're deep in a cave. So here's what's happened. Do this with me. Walk along the ground. Walk, 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 look down at your feet. Walk, walk, look down at your feet. Whoa, there's a deep hole in the ground, and we want to explore that deep cave. Now, if you do that by just climbing down into the cave, you're going to have a really hard time getting back up out of the cave. And that is because caves are formed by something wet. What do you guys think forms caves? If anybody wants to come off mute, Ella and Garrett, you could type that in, or you guys could come off of mute.
Mud.
Mud is really good. Yes. And what is the liquid that's in mud? What's the
Water.
liquid? Water. Good. So water carves caves. So imagine that you're climbing on wet rock. Is that easy to do or hard to do?
Hard.
Really hard to do. That's true. And so it's really dangerous to climb on the rocks inside of caves. So instead, what are we going to climb on? What is this stuff that I've got here?
Ropes.
Ropes. Exactly. Okay, good. So we're going to haul William up as though we're pretending he was hurt. Okay. We'll show you, if he wasn't hurt, we'll show you how we would do it under our own power. I've got this harness on. But we're going to pretend that he's hurt, and he is sitting in this handy dandy chair right here. Now, the thing about William and me is, what are we wearing? What are we wearing?
Helmets.
Helmets. Good. We're wearing helmets. That's very good. It's very important, if you are ever going to do anything with a rope, it's very important that you have adult supervision. Okay. I know kids who've gotten really hurt by using ropes the wrong way. So you have to have a helmet, not just any kind of helmet. These are climbing helmets. And we're going to clip William in to this harness. You'll notice that I have two ropes. Okay. I have the blue rope here, and I have the orange rope. Now, there's nothing special about the colors. The color just reminds us that we have two different ropes. So we're going to first try this blue rope. And the blue rope, you'll notice that I have one end here for lifting William, and I have this other end here that I'm going to pull on. And we call this a one-to-one system. At the top, we have these little things. Anybody want to tell us what this is? You could come off mute, or you could type it in the chat window. It's got a wheel that spins.
Cables.
What do you say?
Cables.
That's cables, not quite. Not quite.
What do you say?
I'm going to be pulling on the rope. These are called
A pulley.
pulleys. Excellent. Good. Pulleys help to reduce the rubbing. And there's a science word for rubbing that starts with the letter F. Does anybody know what that is? Anybody know? Think about it for a second. There's a science word for rubbing. It starts with the letter F. So
Friction.
Friction. Great. Awesome. We're going to do, we have the rope going up, going through some pulleys. and back down. And we're going to try this blue rope first, and then we are going to try the orange rope. I would like you guys to make a science guess. Tell me, what is a science guess called? It starts with
Hypothesis.
hypothesis. Excellent. I want you guys to make a hypothesis. Each of you in the chat window, or you know, we can do it however you want. We can have you guess. If you think blue is easier, say blue or write blue. If you think orange is going to be easier with all the bunch of ropes here, say orange. So who's okay, blue. All right. Rachel says blue. All right. And any other guesses? Dermot, you want to guess? Who else? Ella and Garrett, you guys want to guess what's going to be easier? The blue one right here, orange one. Okay, Ella and Garrett say orange. Okay, great. So we have some different, okay, great. We have some different hypotheses. It's a big word. It means more than one hypothesis. We have some different hypotheses, and because we're scientists, we're going to test our hypothesis. So our first test here is going to be to pull on the blue. Now, William is going to keep his hands away from the metal parts and just hold on here to that webbing. All right, good. Now, as I pull here, notice I'm using both hands, okay? William weighs maybe about 35 pounds, okay? And I'm having to hold on with both hands. I can do it, but you know, I definitely have to hold him with both hands. All right, and you'll also notice that William goes pretty fast when I do lift him, okay? This is a 1-to-1, okay? As my hands go down, he goes up. As my hands go up, he goes down. We're gonna try the other rope system. And we're gonna see.
Can I go all the way up?
In a minute, you can go all the way up. Yeah, he wants to know if he can go all the way up. We will have him go. Yep, have a seat here. All right. Great. Now, we'll pull on this orange one here. And the first thing you notice is that I'm just using one hand. And the second thing you'll notice is now I'm just using 2 fingers. Okay, I'm holding William with just 2 fingers. There's no way that I could do that on the other rope. The other thing you'll notice, I'm gonna pull a whole bunch, and watch William as I pull a whole bunch. He only moved a little bit as I pulled a lot, okay? And that means that this system here, if you said orange, you are correct. This system here, the 5-to-1, there are 5 ropes here, and there's 1 rope over here. So we have 5 here and 1 here. The 5-to-1 is a lot easier to lift him with, but it also takes more time. And so your hypothesis, if you said that orange was going to be easier, you are correct. I have a science tool here. What is this thing?
Ruler.
Ruler, a tape measure. Great. We're going to see how much easier we're going to see how much more rope we have to pull with this one. So this one's 5 times easier than the blue one. How much more rope do you think? Make a guess. How much more rope do you think I'm going to need to pull with this one? It's 5 times easier, but I have to pull more rope. How much more rope do you think I'm going to have to pull?
5.
5. Good. All right. Great guess. Any other guesses? Anybody else want to guess? All right. So I'm going to take this tape measure and I'm going to measure 5 feet on this tape measure. Okay. And 5 feet from where my hand is right down here at my knee. Okay. At my kneecap. And we're going to make sure that William, we're going to measure the distance that he travels off of this seat once he's up 5 feet, or once my rope's been pulled 5 feet. All right, so here we go. Now I pulled 5 feet, and William has been lifted 1 foot off the ground. That's great. So that means that this system it takes 5 times as much pulling to lift him up out of the cave. So William asked if he could go to the top of the tower. So let's do that. We'll tip it up here and you can see him up there at the top. All right, here we go. Now, what you're going to notice when I point the camera at my feet, after I get him to the top, is there's going to be a giant pile of rope at my feet. So we only use this system, this pulley system, if someone is hurt in a cave, because it is really inefficient. And we have to have 5 times as much rope as we would have depth of cave. So let's say the cave is 1,000 feet deep. How much rope do we need? If the cave is 1,000 feet deep, how much rope do we need to lift William up out of the cave?
2,000.
What is 5 times 1,000? Oh, Dermot knows. Tell us, Dermot.
5,000 feet.
5,000. That was a good guess, Ella, but Dermot is correct. 5,000 feet of rope for a 1,000-foot pit. There's the pile of rope on the ground there. Okay, so now we want to lower William back down, and we want to talk about the math of this system. So you guys see that above William, we can count the ropes again. Here we go. Don't count this one. This one's the pulling rope. But above William here, we have 1, 2, 3, 4, 5 ropes. Let's pretend something silly. Let's pretend that William weighs 10 pounds. How much does each of the 5 ropes hold? If he weighs 10 pounds and there are 5 ropes, how many pounds does each of the 5 ropes hold? Who wants to give me a guess about that? You could type it in, you could tell me.
2.
Good, 2 pounds. Okay, awesome. 2 pounds. So if he is 10 pounds, I only feel 2 pounds on this rope, and that's because, see my rope the piece that I'm pulling on? It is directly connected. There's a pulley right here, and this piece that I'm pulling on here, it is the same section of rope as one of the ones that's lifting him. So this is holding 2 pounds, just like all the others. So I only feel 2 pounds. When we go back over to this blue rope over here, we have how much of William's weight am I going to lift? What do you guys think? How much am I going to feel?
I know. 1.
1, exactly. All. Exactly. All. Come on over here. Come on over here to this chair. Stand up. Yep. Walk like a duck. Walk like a duck. Sorry, guys. I will point the camera better. All right. Here we go. Now on this one here, if William weighs 10 pounds, then this rope here feels 10 pounds. And this one over here, they're directly connected. So this one also feels 10 pounds.
10 pounds.
Now on this one, if I pull 5 feet down to my knee, how high is William going to go up? What do you guys think?
Not very high.
You don't think so? Okay. Any other guesses?
5 feet.
All right. 5 feet. Excellent. Good. Okay. So we've got some different hypotheses. We're going to test our hypothesis. Remember, when I take my hand from up here to my knee, that's 5 feet. We're going to measure, and I'm going to have to work really hard to do this because I've got a lot less mechanical advantage. This system over here gives mechanical advantage. This system does not. Okay, here we go. All right, so I'm going to go bring my hand to my knee. One thing you'll notice is that once he's there, I can hold him. And the reason for that is that the pulleys, they have a little bit of friction in them. And the friction is a little different when the rope is moving and not moving. Okay. Whoa, awesome. All right, there's a little error, but William moved 4.5 feet. And the reason that there's error is that this rope right here is stretchy. Okay, William, you can unbuckle if you want. We have a couple different kinds of ropes, and it's very important for safety. If you ever go rock climbing or anything like that, you use the right kind of rope. The color is not what matters here, but this rope right here, this one is stretchy. Okay, I can stretch this rope a little bit. That's a very good thing if you are climbing on a rock and you fall. If you climb on a rock and you fall, what that does is it lets the rope absorb the shock so that your spine doesn't break. This rope right here, this is static rope and it stretches very little. It doesn't stretch that much. And the idea is that when you're in a deep, deep cave, imagine you're at the bottom of the cave and you want to climb up and out of the cave. If you're stretching that rope, you're going to sit there all day stretching the rope tight before you even get off the ground. Okay. Now, one of the things that's true is that the pulleys, they reduce the rubbing. And I was asking you guys about a science word that starts with F. That means rubbing. Did somebody get that?
Friction.
Friction. Good. Friction. The other thing that these pulleys are doing is that they are helping to share the load. Pulleys like sharing. They're sharing the load among the 5 ropes. Now, if we didn't have pulleys, let's say we just ran our rope across another rope. What do you guys think this rope is made of? It's kind of melted at the end. What do you guys think it's made of?
Glue.
It kind of looks like glue.
Fabric.
Fabric is good. Dermot, you want to give us a guess?
Plastic.
Plastic. Excellent. Plastic. Yes. What happens if you get plastic extremely hot? What
It
do you
melts.
Melts. Okay, I want you guys to do this. You're stuck in this. Okay, I'll undo you from the harness. All right. So if you rub your hands together.
They said they wanted it. It might be for.
Go ahead and rub your hands together. Rub those hands together. Tell me what you feel.
My skin rubbing together.
What does it feel like?
Yes.
Keep going. Faster, faster. What do you feel? Is it getting cold? Is it getting warm? What's it?
Warm.
Warm. Okay, you feel heat. Good. So we're going to, do you guys have for this class, we had suggested that you have a fork and a shoelace. Do you guys have that at all? Anybody have a fork and a shoelace? Okay, excellent. Good. So we're going to take your fork, and hopefully you're wearing shoes, because I don't want you to poke your feet. All right. But we're going to put the fork between our feet. Okay. Just about like this. Okay. You guys see that? Now I want you to feel your fork. Okay. What is the temperature of your fork right now? How does it feel? Warm, cold?
Cold.
Okay. Let's run our string or our shoelace under part of the fork like this. So you're gripping the fork tightly between your feet, and we're going to rub the string on the fork. What do you think is going to happen to that part of the fork where I'm rubbing?
Up.
What do you guys think? How's it going to feel?
It'll warm up.
Warm up. Okay, good. So rub on there. And if you don't have your fork right now, this is a super fun thing to do a little bit later once you can get a fork and a shoelace or a string. And William, come on over here and tell us how this feels. William, can you come on over here and tell us how this feels? All right.
Sorry.
All right, here we go. William, feel the fork right here.
Pull up and down, up and down.
It's hot. It's very hot. Okay, good. So we have made a lot of heat on one part of the fork, not the entire fork, just the part where we were rubbing. William, feel down here.
Just keep it tight.
Feel down here and tell us, like right here. How's this? How's that part?
Warm.
Not as hot. Okay, good. So one of the things that's crazy is that we can take a piece of climbing rope. This is called webbing. It's flat climbing rope. Okay, this could lift about 3,000 pounds. The truck that pulls CaveSim is about 3,000 pounds. So this could lift a truck, a pickup truck. Okay, and yet if we rub our string, our little shoelace on this, what do you think is going to happen to this rope? What did Dermot say? Dermot had a great answer. What did Dermot say this was made of? Anybody remember?
Plastic.
Plastic. Good. What do you think will happen when we rub this?
It'll melt.
It'll melt? Cool. How long, why don't you guys each guess, how long do you think it will take to melt this? I'm gonna guess
long
how many
time.
minutes, seconds, hours, what do you guys think?
10 hours.
10 hours, okay, other guesses? What do you guys think? How long is it gonna take to melt through
2
this?
hours.
Okay, anybody wanna guess in minutes? Anybody wanna guess in seconds? Dermot, what do you think? Okay, say again.
5 minutes.
5 minutes? All right, let's check it out. We are going to, all right, William, come on over here. And I'm gonna have you hold on to this, okay? Grip that and step in a little bit so everybody can see. Good, all right, now hold this nice and tight, really nice and tight, okay? Good. Let's do this. All right, you're gonna have to grip it with your fists, okay? There you go. Good. Here we go. I'm going to rub these two together very fast. Grip really tight, like you're going to fall. You don't want to fall. All right. Yep. Up. All right. Grip tight. Grip tight. Okay. Ready? Let's start counting in seconds. You guys want to count?
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
Georgie.
14, 15,
Whoa.
16.
All right, check this out.
16 seconds.
We haven't gone all the way through yet, okay?
But it took 16 seconds.
Yeah, I'm gonna sit down and I'm gonna put it between my feet and we're gonna see if I can go through it even faster this way. All right, so we're gonna run this under here like this. You guys ready? Count again. Ready?
Friction in it.
1, 2, 3,
Hang on, start again. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Whoa, I think that was 10 seconds.
Yeah, 10 seconds.
All right, so what that teaches us is that friction is very powerful and friction can be our enemy. If we are climbing on a rope and we run one rope over another rope, in 10 seconds, we can have somebody fall and get really hurt if we aren't careful. Now, friction can also be our friend, and I'm gonna show you what that looks like. Imagine that you're in a cave, okay? And you've got some climbing gear to climb the rope, to climb up and out of the cave, but your gear is broken. Do you think you could use your hands to climb up? And William, come on over here. We're gonna have you try and climb the rope. You think you can use your hands to climb a climbing rope? What do you guys think? Give me a thumbs up or a thumbs down, or no? Some of you guys are shaking your heads no. Okay, great. William is going to try to climb up the blue rope.
I can't.
Try again, try again. He can get off the ground a little bit, but he can't climb the rope, and neither can I. So if your climbing gear for climbing the rope is broken, you can use a handy knot. So get your string that you guys have there, your shoelace, and I want you to make the following knot. We're gonna do a little alien head, and you're gonna take your fingers, and you're gonna poke your hands in the alien's mouth, and you're gonna wrap them around like this and pull through. And then you're gonna poke the alien in the eye. Silly little story. This here is called a lark's head. And if we go around one more time and tuck these under again, we end up with 2 wraps, okay? And that is called a prusik. And a prusik is really good as a friction knot. William, why don't you come on over here and let's demonstrate for everybody the prusik. All right, so I'm gonna tie a prusik onto my main line here. And just a little bit. And so we're gonna have William pull down on the black strings. Pull down on the black strings, harder, harder, harder. So these black strings that are connected to our main line here, they are not moving. Now, William, I want you to put your fingers under the knot and slide it up the rope. Push. Awesome, good. Okay, so William is able to slide this knot. Now pull on this a little bit, pull on there. When William pulls on the loose ends of the rope of the strings, these loose ends here, the knot doesn't move. But when we let go of these loose ends, we can slide this up and down the rope. So this knot here, this prusik, can easily slide up and down the rope until we put weight on it. And that's because when we put weight on it, there's a certain physics thing that we are increasing. What are we increasing when we pull on this?
Friction.
Friction, we're increasing the friction and the knot will lock. Okay, great. Now this is a lot of work to climb with a prusik. And I am wearing a climbing system that uses little simple machines, okay? And the little simple machines, what is the word descend mean? You guys know what does the word descend mean? If I'm at the top of the stairs and I descend, what do?
Fall?
Falling is good. That's called rapidly descending. Yes. And if you just walk down the stairs, you're descending slowly. What is the opposite? Anybody know the opposite of descend?
Up?
Dermot, you want to come off mute and tell us?
Ascend.
Ascend. Excellent. This little machine right here is called an ascender, and it has some very sharp teeth. in here, okay? And when we take our climbing rope and we put it inside of the device, the sharp teeth, when we close this, they're gonna bite into the rope. And what that means is that the rope cannot slide through the device. It can go one way, but then the teeth grip and it cannot go the other way. It is a one-way system for climbing a rope. So I'm gonna use my ascenders, and I have 2 ascenders on this harness here. This is not a rock climbing harness. This is very different than a rock climbing harness. It's got this chest part, and it's got these ascenders. And so it's important to understand that if you're gonna climb ropes, you have to have the right kind of equipment, the right kind of gear. Okay, so here we go. For safety, I have made sure to tie knots in both ends of the rope. Okay, if somebody was holding the rope and they were lowering me down and they ran out of rope, the knot would stop the rope before it flew through the device that they're using to lower me. Okay, so I'm going to clip my ascenders onto the rope. Here we go. Now I have these handy dandy foot loops. What do you guys think I'm going to do with the foot loops? What am I going to put into my foot loops? What am I going to put in there? My feet, exactly. All right, so here we go. This system has a funny name. It is called the frog. You guys are going to see why it is called the frog. Do you see how I'm stretching the rope? Remember, this is actually a dynamic rope. Remember how I said the problem with dynamic rope is that you'll stand on the ground stretching the rope tight all day before you start going up? Well, this is that kind of rope. It's not that it's unsafe for climbing. It's what we call inefficient, which means it's not very efficient. It's not easy to do. And the reason this is called a frog, watch me. Look, I'm going to jump like a frog. And I'm going to go up, way up the rope. Now this tower here is 12 feet tall. Okay. Before COVID, I did a bunch. It's hard to do caving trips during COVID because you have to go with other people. That's very important. So during COVID, we can't really do caving. But before COVID, I went, this tower is 12 feet tall. I went 13 towers deep on one of my recent trips. Anybody want to do 12 times 13? You could do 12 times 12 and add another 13. Anybody want to do that math? How deep was I? What do you guys think? Anybody want to guess?
know.
I don't know. That's okay. So there are 2 ways I can get down. It's always good to have 2 ways to get down. And by the way, what we're pretending is that we're in the cave and I'm ascending to get back out. And now I'm descending to get back in. So one of the ways that I can go back down is that I can unlatch these devices one at a time, these ascenders, and I can climb down the rope. The other way that I could get down the rope would be to use a friction device. Okay, right here, I have a friction device. Okay, and what's cool about this friction device is that we can take a rope, like our white rope right here, and we can thread it through the friction device. And when we pull on one end of the rope, the brake end of the rope, the bars here, they scrunch together and the rope gets more bent. And when the rope is more bent, then there's more friction. And if I don't pull, then the rope can slide. So here we are. We can slide this on the rope. Okay, I could hook this onto myself and I could slide down the rope with this thing, which is called a rappel rack. Repelling is a word that means to go down a rope. Okay, cool. So we've talked about the safety of caving. We've talked about the physics of caving, going up and down ropes. And one of the reasons that we explore caves, I can't go into outer space. I don't have enough money to buy a spaceship, but I can explore under the ground. And getting to rappel down into a deep, deep cave where very few people have been before, maybe nobody's been before, is really, really exciting. And there are a lot of really cool things that we can learn as scientists about the things that live in caves, about how caves form. So caves are really cool from a science standpoint, and they're really fun from an exploration standpoint. Now, during COVID, one of the things that you guys can do is you can have us come online to your school. So we do programs where we will show you fire demonstrations with old carbide lamps, and we have all kinds of cool games that we play and things like that. So tell your teachers to look up CaveSim, and we can come to your school using Zoom for a virtual field trip. Once we're done with COVID, once we're past COVID, then we can actually bring our giant trailer to your school, and then you can crawl through and you can be a cave explorer.
Okay.
Behind me over here is the warehouse
So,
where we are building our new caves. So you can
okay.
see that in there we've got a bunch of.
So we need a half a cup of candy red hunts.
All right. So do we have any questions from anybody before we let you guys go? I think that maybe we have one more minute. Anybody have any questions about any of the demonstrations we've done today, with friction or pulleys or anything like that? Anybody? I am the guy that built the cave. So I went to school for engineering, and I studied engineering for 5 years in order to be able to make all of the cool circuits that are inside of our big cave trailer, because the big cave trailer is a cave crossed with a computer game. That's what makes it so cool. It's like you try and go through there, kind of like the game Operation. Try and go through there without touching the stalactites and the other cave formations.
Thank you.
Thank you, guys.
Can you maybe try to go through the caves?
Yeah, once we get past COVID, you can definitely do that. One of the things you can do is you can go to our website, cavesim.com, and you can see what the caves look like. All right. Let's see. Mark, do you want to tell me how much more time we have?
I think like 5 minutes to answer questions, but if you're done, that's totally okay too. So
Gotcha. Okay. Yeah, we can definitely. Why don't I show you guys some other cool stuff while we're hanging out here? So inside of our cave, here, let's open this part up. This is the back of the cave. Inside of our cave, we have all of these really cool cave formations. So William, can you please move out of the way? You're in the way of people seeing. Okay, so we have, for example, a stalactite right here. Anybody want to tell me what is the opposite of a stalactite? Dermot, do you know?
Stalagmite.
Stalagmite, exactly. And here on the floor, we have a stalagmite. You guys want to guess? How long do you guys think that it takes for these cave formations to grow? We have cave bacon back here. How long do you guys think it takes for this much cave formation to grow, a cubic inch? Any guesses? Jeremy, you want to come off mute and say it again? Somebody could type it in the chat window too. What do you guys think? Any guesses? How long for this much cave formation to grow? It takes between 100 and 1,000 years for this much cave formation to grow. And these things, the stalactites and the stalagmites, what do you guys think those are made of? Any guesses? Anybody want to put that in the chat window here? What do you think they're made of? These are made of stone. They're made of limestone. And the cave formations, the stalactites and stalagmites, are really, really delicate. They're really, really fragile. And we have something on our skin that's actually not good for these. And a little while ago, I was saying that our cave has electronic sensors behind all the stalactites and stalagmites. And those sensors, they give you points based on how careful you are. So if you touch the stalactites and stalagmites, you lose points. Does anybody know what is it that we have on our skin that's bad for those? Dermot, come off mute and tell us.
Oil.
Excellent, good. We have oil on our skin. And oil and water, do they mix or not? No, they do not mix. So oil and water, they don't mix. And if we get oil from our skin onto the stalactites or the stalagmites, they will stop growing. And that's really sad, because the whole point of going in caves is to see all of the beautiful things that are inside. And so if you touch the stalactites or the stalagmites, they will stop growing. Also in our cave, See if you guys can see back in there. Let's see if you guys can see that. Do you guys see the jar that's sitting there on the ground? Can anybody see that? Back in there. Right here we have an ancient artifact. And one of the things about caves that's really cool is they're kind of like a time capsule from really, really long ago, from, you know, hundreds of thousands of years ago. And so we can go into caves and we can see how ancient people lived by looking at the artifacts that they left inside of the caves. And do you guys think that when we find cool things like that, we should take those things out of the cave with us when we go home? Or should we leave them where we find them? What do you guys think? Anybody want to guess? What do you think, Dermot? You think we should take them home or leave them? We're going to leave them.
Them where you found them.
Yeah, we leave things where we found them. And that is because where we find them in the cave is all part of the story. And if we move things around, if we take things home with us, then we destroy part of the story. And then we can't learn as much about how the ancient people lived. This thing right over here, let's see, this thing right here, this is a cave rescue box. And so it has first aid stuff in it in case somebody gets stuck. Of course, our cave is only 60 feet long, so that's not going to happen. But it's just a fun, we try and make it realistic so people see what our real caves look like. And for any adults who are on the line, there are caving clubs all over the country. Our local caving club is the Southern Colorado Mountain Grotto. And once we get past COVID, you guys can come to actually try real caving. You know, in some cases, you can even bring your kids. Good. Anybody have any questions? Anybody want to ask? You guys can come off mute if you have a question you'd like to ask. All right, and William has disappeared into our cave.